In this video, we will learn about describing motion. And for describing motion, first of all, we need to choose the origin or the reference point. So the location of an object is specified with respect to a reference point. When we say that Sarita's school is 1.5 kilometer northeast of her home, we are specifying position of Sarita's school with respect to her residence. Thus, residence of Sarita is her reference point. We may choose any other reference point as per our convenience. For example, it is clear that we need a reference point to describe the position of an object. Such reference point used to describe the position of an object is called origin. Motion along a straight line, distance and displacement. Just for your knowledge, just remember that erratic and uncontrolled motion as observed in a flooded river, cyclone, hurricane or a tsunami causes devastation to mankind. However, if we control this motion of water and air, we can harness hydroelectric power and wind power respectively. Now, let us consider motion of an object along a straight line. Object starts the motion with point O as the reference point for the object as shown in this particular figure. Now let the position of object 20, 40, 70, etc. as seen with different times given as follows. From the above observation, we can find the total path length covered by the object in a given time. The total path length covered by an object during a given time is the distance covered by it, and it does not depend upon the direction of motion. As you can see in this particular table, that the distance covered by the object in 1 hour, that is 0 to 1 hour, is when the object goes from O to A, and you can see it is 0 to 40 kilometers. In this diagram also, O to A, it covers 40 kilometers, right? And in 1.5 hours, that is 0 to 1.5 hours, we can see that the object is going till B point. So O to A, then A to B. So I can say OA plus AB, that is 70 kilometers. That is simply OB. Now, in 2.4 hours, it comes to C point. Okay, it comes to C point, which means the object first went this way and then take a U-turn and came to this particular point. So here I can say that it is covering O, then B, and then C, right? So I can simply say that it is OB plus BC, that is 70 kilometers till here, and then again return with 50 kilometers of distance covered. So it would be 70 plus 50 kilometers, that is 140 kilometers. Okay. As the path length or distance covered has only a magnitude and can be added algebraically, it is clear that distance covered is a scalar quantity. Now let us discuss the same example in a different way. When the object starts the motion from point O and reaches A in 1 hour and then B in 1.5 hours, its distance from the origin point is 40 km and 70 km respectively, right? However, when the object reaches the position C in 2.4 hours, the net distance from the origin point is given as OC, that is OB minus BC, which would be 20 kilometers. This is what we say displacement of an object. We can simply define displacement of an object during a given time interval as the shortest distance measured from the initial point to the final point of the object. Initial being this origin point and final being this C point. So the shortest path is 20 kilometers, right? It is clear that the displacement has magnitude as well as direction, and hence we conclude that displacement is a vector quantity. Now, magnitude of displacement is equal to the distance traveled of an object only if the object continues to move in a straight line, right? In this figure, the object continues to move from O to A and then A to B in the same direction. Hence, the distance as well as the displacement of the object would be 70 kilometers for OB, and for OA it would be 40 kilometers for both of them, right? Now, the magnitude of displacement is less than the distance covered by an object if the direction of motion of the object changes. In figure, as you can see that when object moves from O to B and returns back and reaches the point C in 2.4 hours, the distance traveled is 120 kilometers, but the displacement is 20 kilometers. Okay. Similarly, in 3 hours, when the object returns to point O, the distance covered is given as firstly 70 and then again 70, that is 140 kilometer as the distance. But the displacement here is 0 because the initial point and the final point of an object are exactly the same. It is to be noted that under no condition displacement of an object can be more than the distance covered by it. As the distance covered has no direction, it is always positive and will get added. However, the displacement can be positive, negative depending on the direction. In the figure, if displacement from O to B is positive, then the displacement from B to C or from B to O is negative. Okay. Now, thus I can say that OB could be plus 70 kilometers displacement, but from B to O it would be minus 70 kilometers, and the net displacement for the motion from O to B and back to O is given as OB plus BO, that is 70 kilometers plus minus 70 kilometers, that would be 0. I hope this topic is clear to you. Thank you.